Hello, I'm your host Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Tim Zerker, Vice President of Engineering Autonomy at Torc Robotics. On today's episode, he'll discuss his team's mission to be the first AV company to commercialize a profitable, autonomous solution for L4 trucking. We hope you enjoy this episode. Tim, welcome to the podcast.
Thanks, Grayson. It's great to be on.
I'm excited to have you here because Torc is developing the Compolite truck. I repeat, Torc is developing the Compolite truck. When you were so kind to put me in the truck, the way it operated, like, this doesn't drive like a truck. This drives like a very nice, polite driver. How did you make the truck drive so polite and so nicely?
I think that's a great question. First of all, I'm really glad that you're calling out the Compolite truck. It's actually kind of one of our missions is to exemplify what a driver should be on the road. And to kind of answer your question, we use some of the best drivers and the truck drivers in the world as role models. And we get them out on the road and we say, hey, how would you handle this situation? How would you behave in this situation? And we try and come up with the best way to handle that situation and then get our truck to do it.
You look at the 1,000,000 milers, the 2,000,000 milers, those individuals, the professional drivers. Do you sit down perhaps in a boardroom, you talk about what are some of the craziest scenarios that you've seen out there on the 1,000,000+ miles, and do you put that into the algorithm so as your truck approaches a potential edge case that these professional drivers saw, you know how to react to it?
Yeah, so kind of on that vein, we've got drivers that have a phenomenal amount of experience, as you said, 1,000,000 miles, 2,000,000, 5,000,000 miles of driving. And we sit down with them and we interview them and we have a back and forth conversation of what have you seen? How do you handle a situation? How would you handle a situation? We encountered a situation on the road. How should that be handled in the future? Did we do it well? Can you rate us on how we did that? And we get that back and forth going between both our development teams and our operations teams to get that feedback in. They've got invaluable experience and we want to mine that. So it's not quite a boardroom setting, but we do sit down and our developers sit down with them and say, how do we handle these situations and what's the best reaction from your perspective?
Wow. So there's professional drivers as part of the Torc team today?
Yes. We've got a bunch of professional drivers at our different testing facilities. So when you went for a ride in the truck, you were down in our Albuquerque testing facility, and we've got drivers down there that are always in our trucks. So every single one of our trucks that's on the road today has an in-vehicle fallback driver. And they're the drivers that I'm talking about, those best drivers in the world that are very highly trained to be that safety driver for our vehicle, but also give us feedback. What did we do wrong? What should we do better?
I want to highlight your safety drivers, if you want to use the term safety operators, their level of professionalism that I saw and how engaged they were at the road. You had the one individual in the right seat that was documenting stuff on the computer, and then you had the professional driver in the driver's seat. And that individual was so glued to the road, paying attention to every single scenario. Okay, I could see his mind working. Well, is this car going to overtake us? Do I have to take control of the autonomy for a safety perspective? That was really impressive. As you're developing the Torc driver, does that level of safety that you're learning from your professional drivers go into the quote-unquote virtual driver?
Yes, that's our goal. Our goal is to make the safest driver out there on the road. And our kind of, as you said, highlighting our safety drivers are mission critical to us. And they give us that really valuable feedback, and they keep us safe. They make sure that we're operating the way we should be operating. And you called out that duo of that safety driver, safety operator, and then what we have, we call a safety conductor, and they're responsible for the safety of the whole mission, right? So they do the communications, they take the notes, they call things out, and they look their second set of eyes for our safety operators to really be that pair. We're obviously driving a Class 8 semi truck down the road, and so we want to make sure that we're on top of everything and we can respond to it as fast as possible.
From a safety perspective, I want to highlight another aspect of the truck. I don't remember the light codes, but when the autonomy was engaged, the lights went on.
Yeah.
And so when I was in the back seat in a seatbelt, I knew, okay, autonomy was engaged, those lights went on. It just seems that all these little things went into the truck to ensure the safest operation possible.
Yes. And that's kind of goes to Torc's safety first mentality. We have an obligation as we're developing this technology to keep ourselves operating in a safe way.
When you're having these really safe operations, you're testing in a safe manner with all the different things I pointed out, and the individual in the right seat taking notes. What type of notes is that individual taking? Is it a pothole? Is it lane markings? Is it perhaps the behavior of the truck? What notes is that individual taking? And then you, as developing the autonomy, how do you utilize those notes to improve the driver?
So it really depends on the situation and the thing that we're testing. So there's kind of different types of notes that they take, but they're doing what we call manual annotation. So they're going in and they're saying, as you said, hey, there was a really big pothole there. Let me make sure it's called out as a pothole. But they might also be saying, hey, there's a pedestrian out on the shoulder half a kilometer up ahead that we've seen. I'm gonna make sure I get it in these notes so that we have that annotation and we make sure that we're able to see the pedestrian out at range and that we're responding appropriately to the pedestrian. So it really, really depends on what they see on the road to see exactly what notes they're taking, but they're trying as much as possible to give us useful feedback in development so that we can make the best driver.
You're testing in Albuquerque, which, to say the least, is not a very friendly place to drive. It's a complex driving environment. There's beds on roads. There's individuals with, I was going to say, odd behaviors that do things on the highway. Do you feel that testing in Albuquerque is enabling you to build a better torque driver?
Definitely. Testing in Albuquerque is an adventure. Albuquerque is a fantastic place. And from a testing perspective, it's even more fantastic. You have the conjoining of two, or the intersection of two highways. So you got I-25 going through, you've got I-40 going through. So it's a freight corridor. You have a lot of interchanges, but then you have a lot of diversity in the types of traffic you see because you're getting people from out of town. You're getting a bunch of different types of drivers who interact differently. And kind of, if anybody thinks back to the different metropolitan cities they get in, everybody's like, nobody drives like they do in Boston, or you got to drive like a Chicagoan, right? Like Albuquerque gets a mix of everybody. And so we see so many different things. But even on top of that, we have a whole bunch of different environments. So I think most people think of New Mexico and they think, desert, it's down on the Southwest, right? It's dry, but Albuquerque is actually at a higher elevation than Denver. So we're at really high elevations. Going into Albuquerque, we're going through a canyon and there are S-turns going through the canyon. So you're at highway speeds taking S-turns. This is a great environment for testing from that perspective. You have weather, so you have rain. It snows in Albuquerque. We've actually had to shut down operation a couple of times just because of the amount of snow that was snowed. You have wind, you have dust storms. And then on top of all that, you get tumbleweeds. So the amount of environment exposure we get in Albuquerque is just tremendous. So from a testing perspective, it's an amazing place to test.
It had that famous wind. That's why the balloons test there. When you're in the Albuquerque Bowl,
Yeah.
you have that aspect. It almost could prepare you to drive in Barstow, California, when the Santa Ana winds go. You're getting that environment. And the other thing I want to go into the geography. Is if you go all the way up to Taos, your elevation change is pretty steep. Are you testing the elevation changes of how the truck's reacting as you going up towards Taos and coming down towards Taos? I'm sorry, coming down towards Albuquerque?
We're testing all of that. So yeah, elevation change is an aspect of what we're testing. You're also testing things like, I think most people that have some familiarity with large semi trucks know that they don't just have air brakes or pad brakes, they've got service or engine brakes, right? So we actually can use the engine to slow us down. And that's actually a really critical part of driving a truck. You don't want to wear the brakes out. You don't want to heat the brakes up. That's not safe. And so those kind of elevation changes allow us to do things like, are we using our engine brake appropriately and our surface brake appropriately when we're testing, which is a very important thing to do when you're working with a Class 8 truck.
What was it like when you first started testing for elevation changes? Because Torque's one of the only long-haul autonomous trucking companies I know that's actually testing elevation. Most of your competitors are focused on, let's call them, flat roads that go for hundreds of miles, and they're not really focused on big elevation changes.
I think that's a really great question. I think here, the testing here, so Torque is based in Virginia, and so we've actually been dealing with elevation for pretty much our whole history, and so it's something we're very familiar with, and we knew right at the beginning was a challenge that needed to be solved.
As you look to solve the challenge of, you described the weather, the elevation, Virginia has a lot of weather as well. Did that impact where you put the LiDARs, the cameras, and the radars as you, let's say, Generation Truck 1 to Generation Truck 2 to Gen 3? Do you kind of really look at where's the most optimal place to place the sensors?
Yes, and I think that's one of the key design elements when you're designing an autonomous vehicle. You want your sensor fields to give you that 360 view. You as a kind of human driver, you're normally looking forward. You need to make a move to the side. You look to the side, and you use your eyes primarily as the driving task. And anytime you need to look somewhere else, you look in that direction. For the autonomous vehicle, we want to be looking in all directions possible all the time, so we can be predicting what's happening. We can determine that it's safe. So if the truck says, hey, I need to make a lane change now, it doesn't start looking about the safety of making a lane change now. It knows that it is or is not currently safe to make a lane change, and what the conditions around it are. So sensor placement is a critical aspect of that. And so we want to optimize not just where we place any one sensor, but where we place them in relation to each other, in relation to the different modalities. So the Torque virtual driver uses LiDAR, radar, and cameras as sensing modalities. And so we want overlapping fields of view with those different modalities, and then we want to cover in all the directions possible.
I noticed when I was in the truck, the prediction, we're going on the highway, and also in this car's trying to come in, and the truck knew before the human brain registered that this person's going to try and be a not nice person and zoom in front of us. And going back to the very polite, calm truck, it slowed down gently, but I didn't feel it as a passenger. How is that possible from a technical aspect? Were you running a prediction scenario to determine, okay, there's a good chance this person's not going to be a nice driver and we're going to have to slow down a little bit? How did you do that?
Yeah, so there's several different things that can be used for that. So one is the one you ran on, is running a prediction scenario. Basically, given the context of the environment that we're in and what the truck is doing and what the traffic around us is doing, what's the likelihood that this person in traffic is going to cut in front of us, right? And there's different kinds of scenarios there. Like, you can tell if somebody's driving aggressively, right? And you want to get away from them or let them over. But you can also tell things like in Albuquerque, where you took your test ride, when you're going through downtown Albuquerque, just like any major metropolitan area, there's constantly on ramps and off ramps and on ramps and off ramps. So I can watch a car come down an on ramp, right, and be in that on ramp lane, and know that they're going to be right next to me and that they're getting onto the highway. And so from that contextual information, the truck can know, hey, this person's getting on the highway, and it doesn't hurt me to either maintain my speed or slow down just a little bit to give them some space. And it probably actually helps the whole situation from a safety perspective to just give them a little bit more space. It's not something that the truck is required to do, but even you or I, as a good driver, we do that. We were looking in, we want to zipper together so that everybody's able to go forward, as opposed to just blocking everybody out.
No, that's well said. And there's another thing I noticed. I don't remember the highway, but it went off to the right, and then you went on an overpass and came down, and 3 lanes merged together. Again, the truck was polite and calm, and everybody merged politely, and the truck didn't have a hiccup. It kept going as the car went in front and the car went back. Is that another example of your prediction software?
Yes. The way kind of the virtual driver works is all these different behaviors are kind of layered on top of each other. So they all play together to determine what the best action to take is. And so what you were seeing there in that specific example was an example of our merge behavior, picking the appropriate place to merge in with other traffic and then sliding us into that location smoothly. And so it's not so much a courtesy situation, because in this case, we're trying to enter the flow of traffic, but all of those kind of behaviors play together to produce that calm, polite truck.
The calm, polite truck, from a driving perspective, you call this a see, think, act approach. Could you talk about Torque's see, think, act approach, please?
Yeah, so actually that's not something that's specific to Torque. It's a kind of a thing in robotics. So when you're talking about a robot and an autonomous thing, whether it's a Class 8 truck or Spot walking around in San Francisco, the way to frame what a robot is doing is in that see, think, act, or see, plan, act. Basically, understand your environment, right? And so you have a set of algorithms and methods, sensors for understanding what the environment is, what's going on in the environment, understanding what your position in the environment is, where you are. We call that localization. And then the next step is that think, or that plan. Okay, now that I know what the environment is, I know where I am, what's my plan? What do I need to do next, come up with that plan, and then you have act on that plan. And then this is kind of like an OODA loop as a terminology, where you loop back and you just do that over and over and over iteratively. So from the virtual driver's perspective, seeing is ingesting all of the data from all the different sensors, using that data to localize ourselves, using that data to find everybody else in the scene, and then planning is that behaviors aspect that I was just talking about. All of these different behaviors saying, what should I be doing in this scenario? Coming up with one plan or one action that we should do. And then we have what we call motion control, which is acting on that plan and driving us to that plan. And then we do that iteratively.
Does that all start at closed course testing as you start to build out the philosophy, do software updates, perhaps you change where you're going to put a certain sensor?
Yeah, so this all starts with design, right? So the way we want to develop is we want to understand what problem we're trying to solve. What is the product that we want to create? That calm, polite driver, that long haul hub to hub trucking, right? We say, what's that problem? And then we start saying, how do we start understanding that? What are the requirements to solving that problem? And then we start doing design and we start doing experiments. And part of those experiments, we run them in simulations. So we do quite a lot of work to develop things in simulation and to develop better simulations of what, of the real world that we can run our designs against. And so even sensor placement being so important, we even do simulated sensor placements and put sensors in different positions and see what their field of view would be, what they would see. If you're talking about a LiDAR, how many points returned on objects, right? Camera, how far can I see with this camera? What's different lighting, kinds of things. We can do that in simulation, but then we also do that in the real world. And the first step of doing that in the real world is taking you to the closed course. So in Virginia, we've got working relationship with Virginia Transportation Institute, VTTI, and they have a track, and it's right next to our headquarters. And we get on that track, which has elevation, by the way, quite a bit of it. But we get on that track and we test different scenarios and we test different setups to figure out what works. And then kind of we go from there and iterate on it. And sometimes we'll take it to a different track. So we've got other tracks that we use around the country to do that kind of closed course testing.
You're taking I'll say, a smart, holistic approach to testing. On the backside of that, are you building in redundancy into the system and the hardware that you're building? So perhaps, I'll give an example. This has happened to a lot of people. It's happened to me. A rock pops up and cracks your windshield on a highway. It's a common occurrence. But in your case, a rock could pop up, unfortunately, and crack a LiDAR. The accounting department's not happy, but the truck still has to get there safely. So is there redundancy if a situation like that happens on the road?
Yeah, I think that's a really fantastic question. So it's one of the really hard things about level 4 autonomous driving is that redundancy. So if you think about developing an autonomous vehicle, there's step 1, which is develop a vehicle that just can drive itself. But steps beyond 1, step 2 and beyond are it needs to drive itself when things start failing, right? So we have what we call ASIL goals. So there are different ASIL ratings. There's just a standard for how often or what the failure rate of something can be and the system as a whole. And our goal for the autonomy system as a whole is the highest ASIL rating, which is ASIL D, which means the chances of it failing are very, very, very low. And so what we want to do to accomplish that is redundancy. And so that's redundancy not just in software, but also in hardware. And so that goes back to what we were talking about. Okay, we have cameras, we have LiDARs, we have radars, right? How do they need to overlap so that I can accomplish my safety goal, right? Not just so that I can make sure I see something, but I also have to guarantee I can see something if one of those things fails, right? Or if one of those things are blinded, right? So that's from the sensor perspective, but you also have redundancy from a compute perspective. So, I mean, I'm sure, I don't know if it's happened to you, but it's happened to me. You're driving down the road and all of a sudden your car just lights up with all kinds of warning lights. And it's like, hey, please pull over, right? I don't want to work anymore, right? That's usually a compute failure, right? And you plug in your little reader and it says, hey, replace this, O2 sensor usually. I don't know why, but right? That can happen too, right? Anything can fail at any time. And so what we want to do is we want to make sure we have those redundancies in place. So we want redundant compute. And then we have to distribute our algorithms to those different computers to make sure that if one goes down, the system as a whole can still accomplish its safety goal, which is to be a calm, polite driver and reach a safe position.
Torque, you have the relationship with Daimler Truck. I think it's an absolutely fantastic relationship. The Freightliner Cascadias are world-renowned trucks. With the relationship with Daimler Truck, do you get access to the redundant systems in the Freightliner Cascadia, or perhaps Daimler's making a bespoke custom Freightliner Cascadia for Torque with all the redundancy built into it?
Yeah, we do have that really close relationship with Daimler Truck. And yes, we do work with Daimler Truck on developing the system as a whole. So Torque is developing the software aspect of it. And to really be safe on road and to really get there, you need a redundant chassis. We need a lot of those hardware parts that you talked about. And so Daimler Truck is working on building that redundant chassis that we can then utilize for the whole system and use as the solution.
As Torque focuses on software, Daimler focuses on making redundant chassis in some of the world's greatest Class 8 trucks. Do you collaborate together from a software perspective? Hey, Mr. Engineer, Mrs. Engineer, if we added this here, we could have a better performance. Is it a collaborative experience, collaborative environment?
Yeah, I would say it is a collaborative environment. We have different levels and degrees of collaboration, but like the closest level, we have what we call our Tormlers, right? These are individuals within Daimler Truck who work directly with Torque. And nobody would let me call them Dorkers, so we call them Tormlers.
That's good.
So, but that's that closest level of collaboration. But kind of that partnership with Daimler Trucks gives us the ability to collaborate at different levels and to discuss what an autonomous truck really needs to be successful.
You mentioned earlier when you eventually commercialize, it's going to be a hub-to-hub model. I believe it's a white paper on your site, or I've seen public statements on the hub-to-hub. How is that approach impacted from the way that you're developing the autonomy stack? Are you developing it differently than some, well, we're going to go all the way from the warehouse 5 miles on, we're going to go on the highway. You say, no, we're going to go hub-to-hub. What is the impact from an autonomy development standpoint for that model?
The impact here is there are different ways you can solve these problems, right? Autonomy and the vehicle being completely alone is just one of those ways. And so you will see in kind of the autonomy industry, there's different levels of how much of the problem are we going to solve, right? When we talk about a hub-to-hub model, what you're doing with that is, one, you're concentrating freight traffic, right? Which is a value proposition, a business proposition for both the customer and for us, right, to have that defined lane, right, that you operate in. The other aspect of it is there are different ways that you can get to the highway, right, and you can control those ways to the highway, whereas if you're trying to drive everywhere, you don't have control over those, and you open yourself up to a lot more things that are a lot more difficult to control.
The other aspect is consumers, parents, moms, dads don't want 18-wheelers going into a local community. When I was in Albuquerque, you demonstrated to me, I think it was, I'll say, 3 blocks, 4 blocks off the highway. It was a demonstration that we view this as being a hub-to-hub, and they showed me how your vehicle could do surface streets. Is that something? So that was I was 3 to 4 blocks. I don't remember the exact race, but very close to the highway. As you're developing the autonomy stack, are you going to set a quote-unquote range? Okay, we're going to operate within half a mile of the highway. Are you looking at it from that way? Because it's constrained. You're going to have commercial traffic. You're going to have lights.
Yeah, we're constantly looking at all of that, and we're working with our partners on where does it make sense to have hubs, and what should a hub look like, and what should we enable between a hub and a highway, right? If you talk about deploying autonomous trucks across the entire country, places in the country look different, right? And so there's different solutions for each of those places. So I think the quick answer to your question is it's a very iterative approach of understanding where do we want to operate, and then how do we do that as safely as possible.
That's a very good point. I've been studying a lot, depots or hubs, whatever term you want to use. I've been kind of geeking out, running all these different scenarios, speaking to everybody to gather as much information as possible on depots / hubs. And I keep coming back to one thing where there seems to be interest, but not really interest. I'd love to get your opinion. Will there be technicians at those hubs? So as I described, a LiDAR gets damaged. Perhaps there's you want to call a Torque certified technician that can replace the LiDAR, replace the camera. Do you see technicians being there to quote unquote launch the truck perhaps?
So I think the official answer I give you is we don't know yet, right? So this is part of that iterative analysis. and understanding what our product needs. The personal answer I'll give you is probably. I mean, I think personally that makes a lot of sense to have a technician there checking out the truck, making sure everything's in order. We working interfacing with our mission control to say, yep, the truck's good to go, giving mission control that, allowing mission control to give that clearance to, yep, take off and go deliver the freight. So I think my personal answer is probably we'll see how it develops over the next couple of years.
How about data? Your trucks generate a massive amount of data. You can't plug an Ethernet cord in, can't plug a USB stick in. They probably violate your security policies, but you can't do it because the amount of data that you get there. Airlines, for example, I consulted for a long time in the airline business, and they called it sneaker net when they would put the IFE, the in-flight entertainment, and individuals run out to the plane and plug it in. Are you developing a sneaker net? Are you just basically pulling out hard drives, putting it into a rack? How are you getting all that data off of those trucks?
No, that makes sense. And you're right. Our trucks collect a tremendous amount of data. And we use that data in development. For exactly how we get the data off the truck, that's proprietary. But we do. We get all of that data off of our trucks, and then we beam it up to our cloud provider. Then we have access to that data for development and iterating to develop simulations, to develop to what we call recompute and run different versions of software against what happened. So we make quite a lot of use of that data.
So perhaps you have SneakerNet. Won't push you on it. Don't know, but perhaps. When your trucks goes to the depot, will the data come off those trucks, get uploaded there in real time, so back at Mission Control they can see everything? Or when it comes back, I'll use the term home, when the truck comes home from its mission, will the data be unloaded?
That's a really good question. And I think that's, again, part of an iterative development as you're deploying these trucks. The real question I think here is, how much data do you need in deployment? I think it's not sustainable to record everything all the time. From when you think about going from one truck to 1,000 trucks, right? And you're trying to record and upload 1,000 times the data, but then you just also don't need that data, right? Interesting things don't happen all the time, right? Most of the time it's just normal driving. You're driving down the highway. If you think about like driving through Texas, right? If you drive through 800 miles of Texas, most of it's just straight road. Right, and something might happen along the way, and you want to record that and save that. So that's aspect one. What do you actually want to record? And then as for getting the data off, that's just working with your partners and saying, hey, what makes sense, right, for sending that data? And there's many different ways you can do that. You can use your sneaker net. You can use over the air to transmit data. There's a lot of different ways to approach that. And Torque, we pride ourselves on, we don't try and say this is the solution. We try and work for what is the solution that makes sense, and that solution might vary.
That ties into what I experienced in Albuquerque is your culture. And I've said this to a lot of individuals. The Torque culture was really, really impressive. It allows you to collaborate. As you collaborate throughout the culture, you're not gathering all the data. Is one of the premises, okay, how do we optimize the data? How do we optimize the operations to give you and the team the tools that you need to build the best compliant driver in the world?
Yes, that's part of what we collaborate on. Are we focusing on the right things? Have we answered the right questions? Are we collecting the right data? And we're constantly evaluating that and saying, do we need to pivot to make sure that we are accomplishing our goals and working incrementally towards delivering that product?
You're well down the road to delivering a really great product.
Thank you.
You're very, very welcome. What is the future of Torque? You're on the road to success, but what's your future?
We are well on the way to success. I agree with you there. I think Torque's future is to be one of the, if not the main provider of L4 semi-truck software to this country and to our customers. And I see that. We're taking an incremental approach to get there. We're working with customers. We're trying to understand what it is they actually need us to solve, instead of creating a product that then we say, hey, but you need this. We want to create a product that says, you told us this is what you needed. Does this fit that? And that's kind of our future, and that's kind of our approach, and that's how we plan to go forward.
You're going forward with an incredible gentleman named Peter von Schmidt as your CEO. The gentleman has the vision for where Torque's going, and to our listeners, I would say what Peter's building and the team at Torque and Tim are building is very special. So be on the lookout for great things from Torque in the future. And Tim, As we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think I'd like listeners to take away that, one, Torque is hiring. So we are actually out there. We're developing really cool technology. We're developing the next innovation, and then probably one of the greatest innovations of our age. And come join our team. We're definitely hiring. And then I want everybody to know that Torque is a collaborative environment, and Torque is kind of looking to develop the best product we can in the best way we can.
If you're in the market looking for a job, I can vouch for the culture of Torque. I love what Tim says. They're developing really cool things. After all, they're making trucks drive themselves, and autonomous trucks are going to have a very positive impact on the economy. Go Team Torque. Develop the driver. Today is tomorrow. Tomorrow is today. The future is Torque. Tim, thank you so much for coming on SAE Tomorrow Today.
Thanks for having me, Grayson.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we speak with Edward Walker at Hub International. He'll share how the company is facilitating a new era of transportation by providing insurance for the mobility industry.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.